In this video, we'll start Chapter 5, Time Value or Money, Part 2. If you remember from Chapter 4, in the last lecture, we talked about time value or money for single cash flows. So we learned about the basic formula between future value and present value, or say the process of compounding or discounting. But if we only look at single cash flows, that's not enough, because in reality, many situations they involve multiple cash flows. For example, if you are looking at a car loan, usually that's 12 payments a year and for 3 years, 3 or 5 years. So that would involve about 36 or 60 payments. And if you have a mortgage, usually 12 payments a year for like 30 years. So again, multiple payments. If you are saving for your retirement, you don't just save once. Instead, you contribute to your, for example, 401k or IRA every month for the next many years. All these situations demand our understanding of time value of money in a multiple cash flow setting. And so we'll start with the future value calculation of multiple cash flows. The idea actually is quite simple. If we have different cash flows at different times, to find out the total future value, we just try to calculate the future value of every one, and we sum them up to get the total. So for example, if we have the following cash flows, $100 today, and $125 after 1 year, and then $150 after 2 years. So all these are invested at different times. You can try to draw a timeline to capture the cash flows at different times. The question is, how much would we have after 3 years if the annual interest rate is 7%? From this timeline, we understand time 0, we invest 100, year 1, 125, and year 2, 150. So all these cash flows hopefully will compound for different number of years. And by the end of year 3, how much would we have as a total amount? Well, for the total amount, we just try to find out the future value of every one, and we sum them up. For example, the first $100, if you think about how much it will become after 3 years, that's a typical Chapter 4 question, if we treat this $100 as a single cash flow. So this $100 will compound for 3 years by 7%. Now the next one, $125, if we invest it at the end of year 1, and then by the end of year 3, this $125 will have 2 years to grow, or say to compound. So that's why we do 125 multiplied by 1 plus the 7% interest rate at the power of 2. The last one, which is 150 here, at the end of year 2, it will have a year to grow. So we have 150 compound for 1 year at the 7% interest rate. And then the last step is to add up all these 3 different future values to get a total future value, and the total future value will be, in this case, $426.11. Now let's look at another example. So if you try to make some money and deposit and save the money so that you can buy a car later. The plan is you deposit $2,000 from the first summer and $25 in the second summer and $3,000 in the last summer. So then, after working very hard and saving all this money, how much money would you totally have so that you can use to buy a car if the interest rate is 5%? So now if you look at the timeline, we are talking about a total of 3 years. So now you are here as a freshman. Next summer, or say the first summer, you're going to make $2,000. You're going to save and invest the money. And then second summer, this much. Third summer, this much. And you want to put all these money together and use the money to buy the car. So if you want to buy the car for your senior year, that would be the end of year 3, or say your third summer, right? So we stop here and try to find out how much is the total future value at the end of year 3. As you see, drawing the timeline is pretty important in terms of helping us to identify how much cash flow we have at what year, and then what is the future value that we need to calculate for what time. Here, for $2,000, we have 2 years to grow from year 1 to year 3. So that's 2 years. So compounding at 5% at the power of 3 minus 1, or say 2, your $2,500 will compound again by the same 5%. Now only for 1 year, because between year 2 and year 3, 1 year. Your $3,000, you will put the money in the account, but that money actually doesn't really have much time to grow or to compound. So if you use 3 minus 3, that's 0. So 1.05 at the power of 0 will simply be 1, and your $3,000 multiplied by 1 is $3,000 itself, simply because it doesn't have time to grow, right? So you're going to put the money into your account, and the next day you're going to take it out. And that is not really going to give you much interest. So then your last step is to calculate all these future values and sum up all those future values, and the total will be $7,830, and you can take that money out of your accounts and go buy a car. Now let's think about a special case of the future value calculation that we just conducted. The special case is what we call an annuity. So an annuity is a cash flow stream where the cash flow amounts are all equal. So instead of having 2,000, 25, and 3,000, which are all different amounts, now we may have an annuity where all the amounts are the same or equal. And also those cash flows occur at a regular interval. So it's either every year or every 2 years, every quarter. So if you have $500 in 1 year and then another $500 after 4 years, that's not really an annuity. When we talk about annuity, we have ordinary annuity or annuity due. So as you see here, the ordinary annuity is when you have each payment occurring at the end of each period. So your first payment will be at the end of the first year, and the second payment will be made at the end of the second year. On the other hand, when you have an annuity due, each payment occurs at the beginning of each period. So in this case, your first payment is actually made at the beginning of the first year, which is now. And the second payment is made at the beginning of the second year, which is actually the end of the first year. Now, if you compare the ordinary annuity and the annuity due, if they have the same payment amounts, annuity due, somehow they always get the payments 1 period ahead or earlier than the annuity due. So keep this in mind when later we will talk about the difference of the values between the matching ordinary annuity and the annuity due. So here we are talking about annuities with a fixed amount. Sometimes there are also annuities that grow at a constant rate. So for example, we have a company paying dividends at $5 at the first year, but then the dividends are growing at a 5%, same 5% growth rate every year thereafter. That can also be considered as an annuity when we have the annuity payments that grows at a constant rate over time. But for this chapter, in this class, we focus on the fixed amount of payment for our annuities. So we only focus on annuities with same amount of payment every time. How should we calculate the future value of an annuity? So it should be consistent with what we talked about before as the future value of multiple cash flows. So remember back here, we try to calculate the future value of every one and sum them up, right? So same idea here. If we want to calculate the future value of this ordinary annuity, we can try to calculate the future value of the first payments at the end of till the end of year 3, and then the future value of the second payment to the end of year 3, and the future value of the third payment, and sum them up, right? So that's why here if we want to put it as a formula, we have the future value of this ordinary annuity as payment, first payment, multiplied by 1 plus I at the power of m minus 1. Because between the first payment and the end of this annuity, how many years do we have? N minus 1 years. Now in this case, N is 3, so you have 2 years. For the second payment, you have 1 year, which is N minus 2, or say 3 minus 2. Right? So the second one is payment multiplied by 1 plus I at N minus 2. So depending on how many payments do you have, or how many years do you have for this annuity, you calculate the future value of every payment one by one, and you sum them up, and that's the principle of calculating this future value of this ordinary annuity. Because of the fact that all these payment amounts are the same, the compounding part, for example, the 1 plus I at the power of 2, and then 1 plus I at the power of 1, and then 1 plus I at the power of 0, it's the same exponential process at a decreasing power, right? From 2 to 1 to 0. People derive a much simpler looking equation based on this pattern that I just described. So what you see here as a future value of this annuity, this equation looks way simpler and shorter, but it's essentially the same as this one. And the reason it can be simplified or shortened is because of the pattern, the same payment amount and then the decreasing power of the exponential process. Anyway, mathematically, same thing. Okay, so what we need to remember is that we have this formula of future value of annuity, and it is the payment multiplied by this annuity compounding factor. This annuity compounding factor is determined by the interest rate and the number of years, or say a number of payments in this annuity. So now if we try to calculate a future value of a 5-year annuity with an annual payment of $100 when the interest rate is 8%, we can simply just plug in these numbers into this formula. So the future value of this ordinary annuity is payment $100 multiplied by 1 plus 8% at the power of 5 minus 1, and then divided by the 8%. So the total future value for this 5-year annuity is $586.66. We can also try to use the financial calculator. I do have videos demonstrating how to calculate the present value and future value of an annuity using your financial calculator. You may want to pause here and check out those videos first, and then come back here and try to practice with this example. Let's see. We have 5 years, or say 5 payments. Interest rate is 8% per year, so IIY is 8. Payment is $100. Now you see here we use payments. Back in chapter 4, all the payments we used was 0, but here, because we have annuities, we're using payments of $100. So with payment of 100 and N as 5, we are telling the calculator this is an annuity of 5 payments, each payment being $100. And we are leaving the PV as 0. This does not really mean the present value of this whole annuity is 0, because later we will see, we'll do the calculation and figure out the present value. But here we leave the PV as 0 just to tell the calculator that in addition to 5 payments, there's nothing else. There's no upfront payment at the beginning. So with no upfront payment and then 5 payments, or say 1 payment each year for 5 years, each payment being $100, we compute for the future value, and it's 586, consistent with the result here. We can apply our understanding of the future value of annuity in retirement saving. So if you start your first job after graduation, your company would have those retirement plans in this case, they contribute 50% of what you contribute. So if you contribute $3,000 per year, the company will add another $1,500. So that is a $4,500 investment contribution into your own retirement account. Suppose you can invest the money and earn a 7% rate of return every year, and you plan to retire in 40 years. And if you manage to put $4,500 every year into this account, and every year it is earning 7%, then how much money would you have in this retirement account when you retire in 40 years? And if you get even luckier and this account is making 8% per year, how much money would you have? So this is a typical future value of annuity calculation. And as you see, if we are looking at 7% per year for $4,500 a year and 40 years, we can come up with about $898,000. That's not bad. Now, if you are looking at 8% instead of 7%, for the same amount that you invest every year, for 40 years, you will actually have more than $1 million. So the key is persistent investment and wait for the long-term wealth accumulation. Now I have a practice question for you. You may want to pause here and try by yourself and check whether your result is the same as mine. In this question, you give your niece $50 per year for 20 years. You put it in an account which makes 7% every year. How much money would she have after 20 years? So payment will be $50 per year and will be 20, and interest rate will be 6%. So you can enter all these numbers into the formula here, or you can enter the numbers into the financial calculator like what we did over here. Either way, you calculate the future value, and it should be about $18,000.